Okay, good day class. Alright, so last lesson we have discussed the basic about vector. Alright, and some operation on vector. Alright, so today we will go to 6.1.3. Alright, 6.1.3 algebraic operation on vector. Add, subtract, multiply. Okay, we don't have division. Again, we don't have division on vectors. Alright, we only have multiplication, same like matrices. No division on it. Okay, so first we will look at 6.1.3.1 additional and subtraction of two parallel vectors. Alright, so even addition and subtraction also we divide into two parts. One for two parallel vectors and for non-parallel vectors. The way we calculate different. Alright, so we look at addition and subtraction of two parallel vectors. Alright, so the sum of a few parallel vectors in the same direction, parallel and same direction, we call it resultant vector. Like what we have discussed before, when we join a few vectors and get the result from the initial point to the end point, then that vector we call it resultant vector. Alright, so let's look at one example. So example, let's say matrix ABC shown in the diagram. They are all parallel in the same direction. A is to the east 2 units, B also to the east 3 units, C to the east 4 units. Alright, so therefore the resultant vector will be A plus B plus C. Okay, so A plus B plus C will be a new vector. This is the name of a new vector, not three vectors. Alright, so have a concept like this. Alright, so the resultant vector will be a new vector with this name. Alright, so this resultant vector are in the same direction as ABC. The resultant vector must be same direction as these three component vectors. Alright, and the magnitude of the resultant vector, the magnitude of this new vector must be same as the magnitude of A plus magnitude of B plus magnitude of C. Okay, so remember, this only happen if they are parallel vectors. Alright, so let's see now we are going to draw resultant vector, this new vector. How to draw this new vector? So same, very simple. Start with A. So A is to the east, 2 units. Alright, 2 units. Okay, then continue with B. B also to the west, to the east, 3 units. So B, 3 units, 1, 2, 3. Okay, so this is A, this is B. Alright, A plus B. Then C is to the east also, 4 units. So 1, 2, 3, 4. This is C. So this line represents the resultant vector A plus B plus C. This is the name of this new vector. And the direction same as these three components to the east. Alright, so this is for three parallel vectors. And A plus B actually same as B plus A. So remember, vector addition of vectors in the same direction is commutative. Commutative means A plus B same as B plus A. Alright, so this is subtraction. Okay, sorry, this is addition. So how about subtraction? Actually, in vector, alright, in vector, we do have the concept of subtraction. And what actually happened for subtraction is plus negative vector. Of course, when we do the question, when we solve, we will just say B minus A. But the actual concept of subtraction in vector is actually addition. But add the negative vector. Still remember the negative vector? This is the actual concept of subtraction in vectors. Alright, so use the example above. We use the same three vectors. Alright, draw the resultant vector of A plus B minus C in the diagram. Alright, so how to draw this? Alright, so A plus B. So again, A to the east 2 units plus B. B 3 units to the east also. So this is A plus B. Alright, minus C. So minus C, as I said just now, is actually at negative C. Alright, so C is 4 units to the east. Alright, so negative C means also 4 units but to the west. So A plus B, stop here. So from here, we go back 4 unit. All right, because minus C ma. Go back 4 unit. So this is negative C. All right. So the initial point is here. And the end point is here. Okay. Therefore, this new vector, remember, this A plus B minus C is the name of a new vector. So this new vector will be this one. Okay. So this is a new vector. So A plus B until here, then minus C come back here. So initial point, end point. Stop here. So initial point, end point. So the direction is like this. So this blue color will be this new vector. So this blue color vector is the resultant vector of A plus B minus C. Alright? Therefore, for subtraction, not commutative. Alright? Subtraction in vectors, not commutative. Means A minus B doesn't same as B minus A because it involves negative direction, negative vectors, which is opposite direction. Alright? So this is the addition and subtraction of parallel vectors. Okay, now we will see addition and subtraction of two non-parallel vectors. So if they are not parallel, how we are going to find the resultant vectors? Okay, we use one example to explain it. Okay, so let's say you are given two non-parallel vectors A and B. A is 2 units to the east, and B is what we say? This is 3, right? So 3 square plus 3 square 18. So this is square root 18. Okay, square root 18 unit. Correct? Square root 18 unit to what you call it? Northeast. Alright, so this is A is 2 units to the east. Alright, whereas B is square root 18 units to northeast. Alright, so not parallel. So how are we going to find the resultant vector of these two non-parallel vectors? Okay, so the resultant vectors of two non-parallel vectors can be determined by using two methods. One we call it triangle law, another one we call it parallelogram law. Both also will give you the same answer, just different method. So again, you have learned this one in Form 5 actually. So just like revision. Alright? Okay, so we see the first method, triangle law. So from the name you know lah, since they call it triangle law means you are going to draw a triangle. You can see. Alright? Okay. Alright, so to find the resultant vector of two non-parallel vectors A and B, it is vector A plus B by using triangle law. So we follow all these steps. Alright, so A, reposition the vector so that the endpoint of the first vector will coincide with the initial point of the second vector. Alright, so make sure that the direction of the two vectors are one followed by another, one continue by another. Alright, and not in the opposite direction, not going there, then come back like that. Okay, so this is the first step. Alright, so let's do two lah. A plus B and B plus A. Okay, let's do A plus B. Alright, so A plus B. So A followed by B. So draw A first. So A is 2 units to the east. Like this. A. Alright, okay. I draw here A. Okay, maybe you will ask why want to draw down here, not everywhere? Because I know that B is going up like this. See? So I need space for me to go up. So I stop here. I draw at the bottom. So A plus B. So from here we draw B. B is, you see, B is 3 unit, right? So same. 1, 2, 3, 1, 2, 3. So here. Okay, so this is B. Yes. Alright, so they say reposition the vector means this one that you arrange them lah, so that the endpoint of the first vector, so this is the endpoint of the first vector, coincide with the initial point of the second vector. This is the second vector, this is the initial point. They must be together. So the direction is one followed by another. See? Okay, so the initial point is here. The end point is here. So you join the initial point and the end point lah. Yes. Okay, you can see. You join the initial point and the end point. So draw two arrows lah to show the resultant vector. So this red color one, the name of this red color vector is A plus B. Alright, this is how to find the resultant vector by using triangle law. Alright, so you see a triangle, right? Okay, so how to draw B plus A? B plus A means start with B. Alright, start with B. So from here lah, I start with B. Okay, so B is 3 to the left, 3 to the right, 3 up. So here. Okay, so this is B. Then followed by A. Initial point, end point. Then from here, continue with A. A is 2 units to the east. Alright, this is A. Okay, now the initial point is here and it stop here, end point, right? No ink already. Okay, so you join them, join the initial point to the end point. Okay, this is the resultant vector B plus A. Alright, this is how we use triangle law to find the resultant vector. Okay, then join the initial point of the first vector to the end point of the second vector, the red color one, then you can see a triangle. So this third line represents the resultant vector A plus B and B plus A lah. Okay, now in diagram 1, the resultant vector is A plus B, this one. In diagram 2, the resultant vector is B plus A, this one. Alright, so you compare these two. Let's compare these two. Let's see the direction and magnitude. So from here to here, you see, to the right, 1, 2, 3, 4, 5. Go up, 1, 2, 3. So 5, 3. Let's look at this one. From here, 1, 2, 3, 4, 5. Go up, 1, 2, 3. Same, right? So what is the conclusion? Yes, conclusion is A plus B same as B plus A. Right? They are the same. So means it's true lah. Same like this parallel vector. Vector addition of vectors. Vector addition of vectors in the same direction is commutative. Alright? So vector addition of vector in different direction also commutative lah. Parallel is same direction lah. Not parallel means different direction lah. But yet they are commutative. No matter parallel or not, the resultant vector for addition is commutative. Alright? Okay, so let's say now we draw another one which involve, hold on, let me see. Why got two? The magnitude of the resultant vector. Oh, okay, doesn't matter. Alright, so next, actually, they want us to draw something else which involve the negative anchor. Alright, so remember, 2A minus B is actually equal to 2A plus negative B. It involves negative anchor of B. Okay. Alright, so 2A first. Start with 2A. Maybe you will ask again, then where am I going to draw 2A? Bottom or top? Okay, then you see the next one. Next one involves minus B, you know. B going up. So negative B going down. So you need space to go down. Therefore, I will draw 2A on top. Alright? Okay, so 1A is 2 units to the east. So 1A. Alright? Then 2A means 2 times 4 units. Okay, so this is 2A. Plus negative B. So B is this direction. So negative B go down lah. I mean the position and the orientation same. But just the arrow opposite only. So now, so go down means same lah. 1, 2, 3, 1, 2, 3. So 1, 2, 3, 1, 2, 3. Alright? Yes. So this is negative B. See that? Go up is B. So go down, negative B. You see the line still parallel. The line still parallel. B and negative B must parallel. Just the arrow opposite. Okay. Now the initial point is here. And the end point is here. Alright. So join them. Yes. This one is your resultant vector. The arrow is from initial point to end point. Yes. So this red color one will be your 2A minus B lah. Okay. Alright, so number 3. So remember, just now, look at here. Just now, for the parallel vectors, the magnitude for this new vector same as the addition of the magnitude of these 3 component vectors. But for non-parallel, okay, the magnitude of the resultant vector is the length of the third side. Means the length of the third line, the red color one, this one. All right, and you can see here very clear that the modulus for this new resultant vector is not same as A plus or minus B. Definitely not same, right? You see, A is this, like this, A is here, B is here. A plus B definitely longer than the third one. So they are not the same. All right, so for non-parallel, remember this, are not the same. If parallel, yes. Okay, then number 4, the direction of the resultant vector doesn't same as the direction of the component vector. Means not same as A and not same as B. Just now same, right? If they are parallel, the resultant vector same direction as the component vectors. But for non-parallel, yes, they are not the same. Okay, so this is to the east, this is to northeast, but this is in other direction already. Okay, this one also, or this one to the east, this one to southwest, this one here, another direction. Okay, yes, so this is how you can find the resultant vector. This is how you can find the addition and subtraction of two vectors, whether parallel or not parallel. And for not parallel, parallel very easy lah, just add them up. Non-parallel, you have to use triangle law. Alright, so other than triangle law, we can use another law. Remember, before this, yes, we have one example here. Okay, we have one question here. Draw the resultant vector of x and y. Okay, so this is y, this is x. Don't follow one by another already lah. So just now we know, right, they are commutative ma. A plus B same as B plus A. So x plus y same as y plus A lah. So initial point here, end point here. So just join them. Okay, just join them. Okay, just one simple example lah. Okay, so next we are going to see how to find the resultant vector by using parallelogram law. Okay, I put it here. Okay. You have a new stand, but it's blocked the bottom here. Okay, so how to use parallelogram law? Okay, we are using the same example, A and B. A, 2 units to the east. B, square root 18 units to the northeast. Okay, so find the resultant vector of these two non-parallel vectors by using the parallelogram law. Okay, so parallelogram law follow this instruction. Okay, again, reposition the vector so that the initial point of both vectors coincide at a same point. Just now, triangle law is 1 followed by another, 1 followed by another. But parallelogram law, the initial point of both the vectors must come out from the same point. Alright? Then, join the vectors, make sure that the direction of both vectors are going out from the joining point. See? So we draw this one first. So means that we have to choose one point as initial point. Let's say I choose this one. Okay, I use blue. Okay, I choose this one as initial point. So from the same point, I draw A. So A is 2 units to the east, A. And from the same point, I'm going to draw B. Alright, so B is 3, 3, 3. Alright, 3, 3 here. So from the same point, you see? So this is the difference. A and B both go up from the same point. Just now, triangle law is 1 followed by another. This is different. So after that, draw two sides which parallel to the both vectors using dash line to form a parallelogram. Okay, so this means, okay, A is here, right? So a line parallel to A. Sorry, B. This is B. A line parallel to B. Here, I draw it by using dash line. Okay, then another line parallel to A. This one. Okay, so you see, you form a parallelogram law. You form a parallelogram. This is why we call it parallelogram law. Alright, so where is the resultant vector? Okay, then the resultant vector A plus B is represented by the diagonal. Alright, the diagonal of the parallelogram. Which diagonal? Parallelogram have two diagonal, right? This one or this one? Which one? Which from the of which the vectors form the two adjacent sides. In short, they came up from the same point. So this is the initial point for A and B to go out, right? So the resultant vector will be the diagonal came up from the same point also. So from here to here, this diagonal. Yes. Okay, so this is your A plus B. Alright, so let's see, when you compare the A plus B formed by using the, I show here, you compare the resultant vector formed by triangle law. Just now we draw this one, right? Triangle law. This is parallelogram law. So you see, they are actually the same. Alright? You see that? You see the red color one, you see 1, 2, 3, 4, 5, go up 1, 2, 3. So you see this one, the red color one, so from here 1, 2, 3, 4, 5, then go up 1, 2, 3. Right, they're actually the same answer. They give you the same answer. Just that one we use triangle, one we use parallelogram. Okay? Can compare both methods. Alright. Alright, next. So then the resultant vector, say already. Okay, so this is how you use parallelogram law. Alright, so how we are going to use parallelogram law to draw this one? Okay, so same. But now again we involve minus, go down. Okay, go down. I need some space to go down. So I choose the initial point here. Okay, now I choose the initial point here. Just now I choose bottom because just now B go up. Alright, now involve negative B. So I need space to go down, right? So I start the point here. Okay, A, hold on. 2A, no. I start the point here, sorry. Because 2A going this direction, okay, going this direction. Alright, so start with this initial point. This one the one, okay, 2A. So 1A, 2A. So stop here. So this is 2A. Alright. Not enough space, can. Sorry. Okay. So 1A, 2A. Not enough space. Okay. Okay, we try again, Okay, we try again. Okay, so I need 3 to go down. Alright, so I think okay, it's fine. So I choose the initial point here. Okay, this is the initial point. Alright, so from here to A, so 1A, 2A. So not enough space, I go out a bit blue color, sorry. 2A. So this is 2A. Alright, then from the same point, see, from the same point, I need to draw minus B. So B is going up. So minus B going down from here. So 3, 3. So 1, 2, 3, 1, 2, 3. So here. Okay, this is a negative B. Okay, so parallelogram law, remember, choose an initial point. So both vectors come up from the same point. Alright, so this is 2A, this is minus B. Okay, so next step, draw the parallelogram. So parallelogram, the line parallel here is 4 units, right? So 1, 2, 3, 4. 1, 2, 3, 4. Dash line, sorry. Dash line. Then join these two, you get the parallel. You get the line parallel to negative B. So you get the parallelogram. So you get the parallelogram. Okay. Then where is the resultant vector? So it's the diagonal come out from the same point. So this is the diagonal that we want. Yes, this is your 2A. This is your 2A minus B. Alright, so let's compare to the 2A minus B that we get from triangle law. So just now we get this from triangle law, 2A minus B. This is a 2A minus B that I get from parallelogram law. So you compare, same or not? Same, right? From here you see 1 unit to the east, 1, go down, 3. So this one also 1, go down, 3. So you see they give you the same answer. Alright? Okay, so let's look at example 6.1.2.b. Okay, you're asking to draw the resultant vector of R and S by using the parallelogram law. Or R and S means R plus X. Okay, so remember the step is choose one point to start. Then all the vector come up from the same point. You follow the direction. Okay, so AB I want you to do yourself. AB you do yourself. Okay, I will discuss C. After I discuss C, maybe I will give you some time for you to complete A and B. Okay, so you see, because C is a bit confused. So you see you are given this is vector R, this direction. Vector S is going up. Many students they're confused. Then they straight away draw this one and draw the parallelogram. No, you see, because this vector, you see, two arrow going in to the same point. Like what we call it? Never mind, forgot the term. Alright, but what we want is going up, right? So don't confuse by the diagram. Okay, so means both going out. So I need some space for me to go up, you see. So I will start my point here. Okay, I will start my initial point here. Alright, then from the same point I draw R and S. Which one first also doesn't matter lah. Okay, S first, S to the north 3 unit. So S to the north 3 unit. S. Alright, then R 1 2 3 1 2 3. All means to northeast lah. From here 1 2 3 1 2 3. So R is here. So this is your R. Okay, it's supposed like this. So from the same point, S going up, R going up. Then only you draw the parallel line. So parallel to this one will be 3 unit to the what 1 2 3. Then just join here. You will get another parallel line. Okay, so again you get the parallelogram law. You get the parallelogram. Then the resultant vector will be diagonal came up from the same point. Yes, this one. Alright, so this is your S plus R or R plus S, same lah. They are combinative, right? Okay, so now I will give you no need 5 minutes lah. I'll give you 3 minutes lah. Okay, please complete these two. Now, 3 minutes. All right, okay, can do. All right, so if you have a problem, you can WhatsApp me. Yeah. All right, we continue the polygon law. All right, so what we have discussed in the triangle law and the this parallelogram law involve two vectors only. All right, we just combine two vectors. Okay, how about if we have more than two vectors? All right, so if we have more than two vectors, then the resultant vectors can be found by using polygon law. So only one way, polygon law. All right, so the resultant vector of three or more non-parallel vectors, these for non-parallel vectors, can be determined by using the parallelogram law. This is an example. Okay, I put it down a bit. Okay, so this is an example. All right, so you are given that ABCDE is a regular pentagon. Pentagon, five vertices. Regular means all the sides are the same. Okay, so find the resultant vector for each of the following. So let's look at the first one. We use black lah. AB, so AB is here. Draw the arrow. Plus BC, so BC is here. Then plus CD. Then plus DE. Alright, this one first one very simple lah. They follow each by another. So the initial point is here. The end point is here. Alright, so you see it's connect BB, CC, DD. Therefore, the initial point is here. The end point is here. Therefore, the resultant vector is this one. So the resultant vector is AE. Okay? From the diagram, you can see. From the wording also. Because this is connect. So the resultant vector will be the first alphabet and the last alphabet, AE. All this for, they are the same. Okay, how about if they are not the same? Like this one, BA, but this is DC. Like not the same, right? Not connect. And this is CB. This one cannot, DC, CB. Alright? So one way is, you can rearrange them. You say DC, CB, and followed by BA. If you don't want to use diagram you can do this way. So DC plus CB, then followed by BA. Because it's commutative, right? So we can change the position. Because all involve addition only. Now you see the connection, CC, BB. Alright, therefore the resultant vector will be the first alphabet and the last alphabet. So D, A. Alright? So if from the diagram, how? From the diagram, how to see? Very simple. I use the red color one. BA means here. BA. Okay, BA. This direction, BA. Next one is DC. So DC is here. Okay, follow the alphabet. The direction follow the alphabet. So DC, like this. Okay, the third one is CB. From here to here, CB. If you use the diagram, okay. So when you see the whole thing, you see that it starts from here, the arrow from here to here, from here to here, from here to here. You see, initial point, end point. Okay, therefore the resultant vector is DC, DA. Sorry, right? So you can do this by using diagram or by using wording also can. Alright? So for C, you do it yourself. Okay? Then next, use the same diagram, find. So we want to use this example to explain something. Okay? So you see, AB plus BC, bracket, you see, bracket means find this resultant vector first. Alright, so I think, okay, never mind, I draw a new diagram easier, or else very messy. Okay, I draw another new diagram. Okay, A, B, C, D, E. Okay, so AB plus BC. So AB, BC. So this is the resultant vector. Because it's put in the bracket. Also, it means we have to calculate this one first. AB plus BC. So I get this. Then after that, from this one, we add CD. Then only followed by CD. This is the meaning. So AB plus BC is this one. Then followed by CD. So initial point, end point. So this is the actual resultant vector. Alright, so the answer is A, D. We want the concept of this one thing. Alright, so another one, you draw another diagram. You please draw another diagram. Okay. Okay, you add B, C, C, D first. B, C, C, D. So means the resultant vector is BD. Then from BD, you add AB. This is BD, right? You add AB. So AB, BD actually answer same. Okay, you draw another diagram. You please draw another diagram to show this one. You like what I have done here lah. You draw this one first, then followed by AB. You will get the same answer. Right? So from here, we want to make one conclusion is, so the addition of the vectors, which more than two vectors, okay, is actually distributive. Distributive? Commutative, distributive. No, this is not distributive. This is associative. Sorry, this is associative. The vector addition is associative. Associative means we do this one first or we do this one first. Answer same. Associative. All right. Okay. So what we have done just now, addition and subtraction on vectors by using diagram. By using diagram drawing. Okay, now we will see addition and subtraction on precision vector. Means we don't look at the diagram. We see ij. Still remember your ijk? The unit vector. Alright, this one is actually even easier. Okay, so you see that. Okay, so look brighter. Okay. I push out a bit. Okay, you can see better. Alright. Alright. Okay, so addition and subtraction on precision vector. Precision vector, remember, OP, OQ. So let's say you are given 2 points, P and Q, with coordinate x1, y1, x2, y2 on the Cartesian. O is the origin. So remember, from the coordinate, we can find the precision vector of OP. Let's say OP is R1, which is x1i plus y1j, or right in the column vector form. So OQ the same. Alright, therefore OP plus or minus OQ will be R1 plus or minus R2. Means this is OP, this is OQ, plus minus. So just add the X component and the Y component. Very simple, right? This is for two dimension. So 3 dimension also the same. Let's say P and Q is in 2 dimension plane with coordinate x1, y1, z1, x2, y2, z2. So when you want to add or subtract, same. Same method. Just add one more element, z. Alright. Then to calculate the distance between points, especially in 3 dimension. 2 dimension also same, 3 dimension also same. Alright. So vector PQ, we want to find the length or the distance between P and Q. So means vector PQ. So the modulus. So PQ is OQ minus OP, right? So OQ is Z2, Y2, X2, Y2, Z2. OP is X1, Y1, Z1. Just calculate. Then to find the modulus in 3 dimensions, remember this formula? X squared plus Y squared plus Z squared. You can refer to page 6 in the notes. Alright, page 6 in the notes. We have already explained how we get this formula. If 2 dimension is just square root X squared, Y squared, right? So 3 dimension is X squared plus Y squared plus Z squared. Alright, we have shown in page 6, can refer back how we get this formula. Alright? Okay, so next. Okay, so next will be, we will see some example. Okay, make it brighter. So we will see example 6.1.3.3. Okay, first we will look at your textbook. Okay, we will look at the textbook, checkpoint 6.1. So in my textbook is page 257. Okay, we will see question 2. You can see, Alright, we will see question 2 like this. You are given vector A, 1, 2, 3. Vector B, 2, 0, 1. Okay, so they want you to find modulus A, modulus B, modulus A plus B, modulus A minus B. Alright, so this is the question. So this is the solution. Alright, so very simple, very easy question. It's given A and B, right? So modulus A, modulus of vector A, very simple, follow the formula, square root 1 square plus 2 square plus 3 square, so square root 14. This is already the simplest form. Cannot simplify anymore. I will discuss C. Modulus of A plus B. Alright, so remember A plus B is a new vector. So we have to find this new vector first. So this is A, this is B, add them. This is a new vector, you see. So A plus B is this new vector. Alright, so if expressed in IJK form, it will be 3i plus 2j plus 4k. So to find the magnitude of this new vector, so 3 square plus 2 square plus 4 square, so square root 29. Alright, so means you have to find this new vector first, then only find the modulus. Okay, because they are non-parallel. This is 1, 2, 3, 2 is 2, 0, 1, definitely non-parallel. So you cannot just add their modulus. You cannot add modulus A, then add modulus B. Cannot. You must find the new vectors first, then only find the modulus. Alright, so please do your B and D. I want you to do B and D as homework. Alright, so next will be two partial questions. You see how they can ask related to this part, or subtraction and addition. Alright, in STPM. Okay, so STPM 2003. You are given two vectors. Vector U. Vector U is cos rho I. Or this is just a symbol. We call it rho. Cos rho I. So cos rho is the coefficient. Vector I. Plus sine rho j. Whereas vector V is cos theta I plus sine theta j. Okay, and I and j are perpendicular unit vector lah. You know lah, I in the direction of x axis, j is the direction of y axis. Show that half of the modulus of u minus v. So this is a new vector u minus v, same as this one. 5 marks. It involves modulus, you see. Okay. All right. So this is the solution. See. So you are given U and V. I write it in column vector form. I write it in column vector form. Alright. I write in column vector form. So U and V. So U is cos rho, sine rho. V is cos theta, sine theta. Alright. So the question start with. Hold on, let me see. Okay, can see. So the question start with half modulus u minus v. So I find u minus v first. So this is u, this is v. Alright, so u minus v, just write them together lah. Alright, so this is a new vector. Okay, so the modulus of this new vector will be, half is still there. So square root x square, so this square, plus y square. This is 2 dimension only lah, or ij only. So I expand this one. So cos rho square, alright, cos theta square, 2 cos rho cos theta, alright, plus expand this one, sine rho square, okay, sine theta square, then minus 2 sine rho sine theta, this one, expand it. Okay, after expand, you see, cos rho square plus sine rho square, this one, cos square plus sine square, 1, right? Yes. Okay, so another one is cos square theta. This one I write 1. This is theta, sorry. Sorry, this is theta. I write wrongly, this is theta. Okay, so cos square rho plus sine square rho, this one. Okay, this one. Cos square rho plus sine square rho. Cos square sine square is 1, no? Alright, then cos square theta sine square theta. Cos square theta sine square theta, 1 also lah. Alright, so this one minus 2, this one also minus 2. So I factorize out minus 2. So become cos rho cos theta plus sine rho sine theta. Because I factorize out minus 2 already, so here is plus lah. Okay, so we are going to use the formula for cos. So cos plus sine is cos rho minus theta. Remember? Cos A minus B. Okay, cos sine is cos minus. We use the identity. Alright, 1 plus 1 is 2 lah. So minus 2, this one formula. Okay, then how from this step to go to this step? We are using half angle formula. Remember the half angle formula? If forgot, please refer back chapter 1, okay? Okay, so the half angle formula say cos A is 1 minus 2 sine square A over 2. Cos is come from, remember, cos 2A. Cos 2A got 3, right? Can be cos square minus sine square, can be 2 cos square minus 1, can be 1 minus 2 sine square. Okay, so from this double angle formula, we get this half angle formula. Alright, so all the 2A change become A ma. All the A become A over 2. So 2A over 2, so A. So we are using the third one, 1 minus 2 sine square A. Okay, we are using half angle formula. So imagine that now this whole thing is A lah. This rho minus theta is your A lah. So cos A. So cos A is 1 minus 2 sine square A over 2 lah. Okay. Okay, so now we elaborate. So 2, elaborate this bracket lah. So minus 2 multiply 1 minus 2. Minus 2 multiply minus 2, positive 4 sine square. Okay, 2 minus 2 no more. So square root 4 sine square, this one. So square root 4 is 2. Half is still here. Square root 4 is 2. Square and square root no more. So 2 and 2 simplified. So left sine rho minus theta over 2. I can write as sine half multiply rho minus theta. You can see. Okay. Alright, so this question give you 5 marks, which involve trigonometry. Okay. Alright, next. STPM 2007. Okay, so how the questions look like? The position vector of point A, B, C, D related to an origin are this one. Alright, so that again, this is 2 dimensions only lah. They give you a position vector. So follow the sequence. This is your OA lah, because this is your OB, this is your OC, this is your OD. Alright, part A. This question got 2 parts. Okay, so here we only discuss first part. Show that for any value of x for which A, B, C, D is a parallelogram. 3 marks only, so means not that complicated. Okay, so this is the solution. Alright, this is the solution. So just now they give you, right? So I write everything in vector column form lah, easier to calculate. Okay. So OA is 1, 3, OB is -5, -3. Okay, here, follow here. 1, 3 lo. Okay, OB is -5, -3 lo. Okay, OC is x minus 3, -6. Okay, OD is x plus 3, I only, you see? X plus 3, I only. Okay, so J is 0 lah. Alright, no J. Okay, right, so I just simply draw one. I don't follow the actual measurement, so I just draw one parallelogram. Okay, so A, B, C, D. We always label anti-clockwise. So what is the definition for parallelogram? So parallelogram means the pair of the opposite side must be the same. Same means same direction, same magnitude. Alright, the opposite pair. So as long as you can show one of the pair are the same, then you can say that it is parallelogram. Let's say if AB same as DC, same means same direction, same magnitude. So when you join them, definitely another pair also same. Also just need to show one pair. Okay, I choose AB and DC. You can choose BC and AD, up to you. I just choose one pair. Okay, I choose AB. So to find AB is using the position vector formula. So AB is OB minus OA. So this is OB, this is OA. So you get -6, -6. Because the question give me in IJ form. So the final step, I express the answer in IJ form also lah. Also is -6I minus 6J. Because I'm using AB, this direction. So the opposite one, I use DC lah. I don't name it CD because when you name it CD, then different thing already. It become opposite already. Alright? So I name it, I find DC lah. So DC. So vector DC is OC minus OD lah. This is OC, this is OD. Okay? So you see X minus X, no more. So -3, -3, -6. -6 minus 0, -6. So DC is -6I minus 6J. Alright? So from here you compare. AB is this one. DC is this one. Same, right? Therefore, AB same as DC. Okay, and the conclusion is ABCD is a parallelogram with, I forgot something because the question says show that for any value of x. So ABCD is a parallelogram with any value of x. So what is the meaning of any value of x? Sorry, can you see? Okay, what is the meaning of any value of x? Means that, you see, no matter what is x, no? X can be anything, but after we combine them, the x disappeared. So what value of x doesn't matter, right? Because at the end, the x will disappear. All right? So 3 marks only, this question. Okay? All right. Okay? Okay, so we have finished subtraction and addition and subtraction of vectors, whether parallel or non-parallel. So I think I will stop here first. Okay, I will stop here first. So your homework, only a few homework only, right? Okay, not many homework. So just complete it. All right. So after that, the next video, or maybe tomorrow, tomorrow I will continue with multiplication of vector. This is more important. This is still simple. Multiplication of a vector by a scalar is still simple, where you have learned this one in SPM. The following one is something new. Okay, so I think we will continue tomorrow this one. Okay, thank you, class.